Hi guys, so today we're on the foldable that looks like this, rate of change, slope, and rate of change. We're going to start by looking at slope. Slope is represented by the letter M, and we can find slope on a graph or using rise over run. So rise over run. Let's see what that means. So if we have a graph of a line just like this, we have point A and point B. So the slope, or how steep this line is, we can figure that out by figuring out how far we go up and over, or down and over. Well, let's look at up and over. So up, we go 2 units up, so our rise is 2 units. Rise is 2 units, and our run is how far we go side to side. So we go 1, 2, and 3 units to the right. So that's a positive 3. So our slope for this line over here is 2 over 3. Let's look at this line going negative, or going down. Okay, what that means, let's put that over there. Again, we're going to do rise over run from point A to point B. We're going to go this way and to the right. So rise, we go 1, 2, and 3 units down. Well, when we're going downwards, that's a negative movement, so that's going to be negative 3. And 1, 2, 3, 4, 5 units to the right. Any movement towards the right is a positive movement, so that's a negative 3 over a 5. So that's our slope, negative 3 over 5. Well, what if we were to go this way instead, right? So we go up and to the left. Let's figure it out. We go 1, 2, and 3 units up. Well, going up is a positive movement, right? So we have a positive 3. And then going 1, 2, 3, 4, and 5 units to the left. Well, going towards the left is a negative movement, right? So our slope would be 3 over negative 5. Well, both of these are the same numbers, right? Negative 3 over 5 or 3 over negative 5 represents the same exact number. So it doesn't matter if you go down and to the right or up and to the left. The only thing that matters is you always must go rise over run. So you have to go up or down first and then side to side. Okay, so let's look at another example. Over here is an example of a zero slope. Oh, sorry, before we go on to zero slope, let's look at the line over here. We have a line going this way and a line going this way, right? Well, if you look, this is a line going upwards, or it's going in the positive direction. Well, our slope is also a positive number. Whenever your slope is a positive number, your line is going to have a trend that goes upwards. And then whenever your slope is a negative number, your line is going to have a trend that's a downwards facing trend. Okay, so now on to zero slope. Over here we have point A and point B on this horizontal line. So we're going to do rise over run just like previously. So how far do we go up or down to go from A to B? Well, we don't go up or down at all, right? So our rise is 0 and our run is 4 units. 4 units, 0 divided by 4 gives us 0, so our slope for this horizontal line is 0. Slope of any line is 0. It has a slope, but the slope is 0. Okay, and then this line, the vertical line over here, we have point A and point B. Again, we're going to find our rise over run. We go 1, 2, 3, and 4 units up, so 4 units up, and then run Well, we don't go side to side at all, so it's going to be divided by 0. Well, remember, we can't have a denominator of 0. Whenever you have a denominator of 0, your slope is undefined. Or it's a no slope, or has no slope. There you go. Let's look at how to find a slope when we are given just 2 points. Well, remember, these were still 1 and 2 points right over here, right? But we used the graph. Now we're only given the coordinate points, or ordered pairs. Both of them are the same word. Coordinate points or ordered pairs represent the same thing. Again, slope is m, where m is equal to y2 minus y1 over x2 minus x1. What does that mean? Well, let's figure it out first. Well, we know whenever we have an ordered pair, our first number is always an x, and our second number is always our y, right? So you go down the x-axis 5 units, and then you go up the y-axis 1 unit. Same thing here. The first number represents an x value, and the second number represents a y value. Now we have the first point and the second point. So all we're doing is saying this is my x1 and y1, and this is my x2 and y2. Now we can take these numbers and plug them into our formula. So let's do that. y2 minus y1 over x2 minus x1. Well, what's my y2? y2 is 3. So 3 minus, from the equation, y1. y1 is 1. Divided by x2. x2 is 8. Minus, from the equation, or formula, x1 is 5. 3 minus 1 is 2. 8 minus 5 is 3. So again, our slope is 2 over 3. So all we're doing is assigning x1, y1 because this is my first point, and x2, y2 because this is my second point. So now again, the more you write this equation or this formula, guys, the better chance that you'll memorize it. So keep practicing, keep writing it over and over again, just like I am. So y2 is -5, -5 minus y1, y1 is 4, over x2, x2 is 6, 6 minus, from my equation, x1 is -6. Please make sure you put that in parentheses so you keep those two negatives separated. Well, -5 minus 4 is -9. Same signs, add and keep. And over here, two negatives right next to each other. You can turn that into a positive, or negative times a negative is a positive. So 6 plus 6 gives me 12. I can reduce this down to -3 over 4 by dividing both the numerator and the denominator by 3. So my final answer, or my slope, is -3 over 4. 0 slope over here, x1. I don't know why I wrote that negative in there. x1, y1, x2, y2, right? So y2 minus y1 over x2 minus x1. So again, we're going to take our y2, which is 2, minus y1, which is 2, over x2, again, that's 2. I don't know what is going on with my board. x2 is 2 minus x1 is -4. Uh-oh, it's going to turn off. I have a feeling my computer's going to turn off. My -4. There we go. So now this situation is kind of like this, right? Where we have two negatives next to each other, and then you have a 2 minus 2 up on the top. So I'll let you guys figure out that slope on your own. And again, I'll help you set this up. x1, y1, and x2, y2. Go ahead and plug those numbers into y2 minus y1 over x2 minus x1. If you look on the side, this one should be a no slope. That means you should end up with a 0 in the denominator, and this one is a 0 slope, so you should end up with a 0 in the numerator. Make sure you do the math. Set up your problem first and then do the math and check that you do end up with a no slope and a 0 slope for those two. I'll let you finish those two on your own. Over here, it says tell whether the rate of change is constant or variable. So all you're going to do for these problems, remember, your tables, whenever they're set up like this, your top row is your x values and the bottom row is your y values. You're going to take your y values and divide it by your x values. And then if all of the ratios for all of these relationships match, you are good to go, and it is a constant relationship. If they do not match for every single one of them, then it is a variable rate of change or relationship. Okay, so again, take your y, divide it by your x, so 1 divided by 12. When you do that, let's see, you get 0.083. Let's do the same thing for 2 divided by 24. 4 divided by 48. 7 divided by 84. And 9 divided by 108. That's 108. There's a sneaky 1 right there. It's right there. But yeah, that's 108 right there. Okay, so when you do all of these, okay, when you fill all the, or do all the math for all 5 of these, you end up with 0.083 for all of the relationships. So it is a constant rate of change. So we're good to go. It's a constant one. So let's look at this example 2. Again, you're going to take your y values. My bottom one is always y and the top one is always x. So you're always going to take your y's and divide them by your x's. Well, 1 over 12 divided by 3 over 38. Or sorry, 1 over 12 equals 3 over 38 equals 7 over 90 equals, and then 8 over 108. Well, we know from the first problem, right, 1 divided by 12 is 0.083. Let's figure out 3 divided by 38. That will give us 0.0789. Uh-oh, those two do not match. We do not need to keep going because even if one of them doesn't match the rest of the relationships, that means it is a variable relationship. We don't have to go any further when we're just figuring that out. Okay, I'll let you guys do example 3 and 4 on your own. All you're going to do is take your y's, divide them by your x's. So for the first one, 7 divided by 1, well, that's going to be 7. 15 divided by 2. 32 divided by 5. And 58 divided by 9. See what answers you get, and if they are all the same answers, then this will be a constant relationship. If they are different answers, then it will be a variable relationship. Do the same thing here. Take your y's and divide them by your x's. So 14 divided by 2, 21 divided by 3, and so on and so forth. Make sure you check every single one, especially on standardized tests. They will give you something that does not always match up. Okay, do example 5 on your own, and we'll do unit rate in class.